Saxon Algebra 1, Lesson 21. Students, I am in math teacher heaven right now. It's well after midnight. The house is quiet. One of my daughters is upstairs teaching English to people from all around the world. I can hear her chatting with them. She used to teach students in China. That program kind of went bust because of some new laws from the Chinese government. So now she talks to adults all around the world through a program called Cambly. So anyway, she's upstairs chatting. Gracie's asleep on the couch. The cats are tucked in bed somewhere. It's raining outside. It's kind of windy. It's kind of spooky. And I get to teach you about the product rule for exponents. Oh my gosh, this is such an exciting time. This is a lesson that is going to stick with us for years. You'll be using this forever. There are going to be 3 rules for exponents. This is the first one. We will add as we go. For now, I just want to show you the one rule. If you have a base and it has an exponent on it, and you're multiplying it by another base. Now, the base could be a letter or it could be a number. We're using X just to stand for any base you'd like it to be. And let's say there's an exponent on this number as well. If you want to combine those, you can. You just add the exponents. Oh my gosh. When you multiply matching bases, you can add the exponents. And this is a good time to also point out that anytime you just have a plain letter or number, that has an exponent of 1. We don't usually add that, or we often write it without it, is what I mean to say. But you can use either of those notations. If you don't have a 1 and you want it, go ahead and put it on. If you have a 1 and you don't need it, pop it off. That's helpful because sometimes we might have something that looks like this and we go, oh, but the second one doesn't have an exponent. Yes, it does. It has a 1. All right, let's practice. This is a very straightforward lesson. Let me just check and see. 21.1. Let's see how many examples there are. 1, 2, 3, 4. Although one of them has that A, B, C, D stuff that John is so fond of. I think it's cheating. Oh, I see what the problem is. I'm looking at the wrong lesson. I was looking at 19 going, these aren't product rule for exponent problems. What was I thinking? Okay. This lesson does have a second topic, kind of, but we'll just dive in. The first problem looks like this. That's an X. All right, so we have 4 bases that are being multiplied together. Each of them has an exponent. We notice that 2 of them match, right? We have 2 bases of X and we have 2 bases of Y. Notice how I'm using underlines, and I could use squiggles or circles or whatever I wanted, but I'm identifying which ones go together. That's going to help me A, combine the right ones, and B, make sure everyone that can be combined is combined. All right, the way I like to show this, exponents are annoying because they're little and fiddly and they squish up at the top. By their nature, they're quite small. So what I like to do is simplify my problem. What I'm saying is first I'm going to look at the base for X, and I'm going to add the 2 exponents using the product rule for exponents, and that will give me an exponent of 7. Then I do the same thing for Y. That's a 2 and a 3. So my final answer is X to the 7th, Y to the 5th. That, my friends, is the product rule in action. You like it? It's easy, it's straightforward. When we learn the other rules for exponents, sometimes it's a little tricky to remember which one you use when, but by and large, these are very straightforward. Most students groove. Okay, this one is a wee bit funnier. I'll show you. Oh no, this one isn't funny. John's being nice to you. He's giving you straightforward ones so far. Okay, I'm just making sure I copied it correctly. Yeah, that looks good. The first thing we do is we make sure that we're multiplying everything together. Yes, there's no plus or minus signs in there, so that's all multiplication. Then we check to make sure that every base has an exponent, and these all look good. Remember that if it's just a plain letter or number, we can put a 1 by it, right? Because every base is to the first power. I wrote this on the other page, but I'm just writing it again. I'm going to write the whole thing again, just like I want you to do. Okay, so the product rule says that if we're multiplying matching bases, we can add the exponents. So let's do it again like we did last time. Here are the x's. 2 plus 3 equals 5. Here are the y's. 3 plus 2. Those turned out the same, didn't they? And I see we have an m, a base of m, but there's just the 1. So in my answer, I'm going to write him first. M to the 5th, x to the 5th, y to the 5th. They all ended up being the 5th. All right. Notice that these are still exponents, even though I'm writing them big here. I'm just looking at the exponents only to do my calculation here to make it easier. All right, 21.3. All right, that seems like something Zyx. It sounds like a prescription drug that would be advertised on TV during the Super Bowl, don't you think? Okay, what we want to remember here is number 1, we check to make sure it's all being multiplied. If we decide to add or subtract in between these terms, then the rules have to be applied differently. It's the same rule, but we just have to think about it differently. So everything's just one big chunk of multiplication. Cool. Everything has an exponent. No, we're going to have to fix that, aren't we? These two are plain numbers, so we're going to give them their little, I call them angel ones sometimes, because you know what? They're always there whether we can see them or not. They're like angels. Okay, now we're ready to do our thing. X, let's see, I'll circle this time. There's x to the first power, x to the third power. So it's 1 plus 3 equals 4. And then our y base has a 1 and a 2. And our final answer is x to the 4th, y to the 3rd. I like these alphabetical. Okay, for today, for this lesson, for 21 and maybe 22, I would like you to go through the process of writing this out like I do. Obviously, you don't have to make it giant-sized font like I do, but go ahead and write this out. The problems are going to get more complicated, so I want you to know how to set it up this way. Then, going forward, sorry, I was yawning. I was watching the water stream down the windows. If you feel like it's easy enough to add these numbers in your head and just jump right to this, that's fine. But I'll tell you what, it's going to get crazier. So I want you to know how to do this if you ever need to do that. Okay, here comes another one. This is 21.4. Okay, I copied it down exactly the way John gave it to us. I'm just double checking to make sure I wrote that correctly. Now, I didn't do it this time. I copied it just the way John did. But if I was a student during my homework, I wouldn't even bother to skip over these. I'd automatically give them the ones right away because I know I'm going to need them. I know John's asking me to combine things as much as I can. So go ahead and just put the ones in if the bases have no exponents. Okay, let's go alphabetically. Let's start with the M's. There's one. There's one. There's one. So it's going to be 3 plus 1 plus 2. This is the product rule for exponents. I'm adding the exponents on bases that are being multiplied together. That gives me 6. Then I'll do P, and that is a 1 and a 5. And then I'll do my X, and let's see, I'll draw arrows to that one. That's a 1 and a 4. All right, so my final answer is M to the 6th, P to the 6th, X, no. Oh, I see what I did wrong. I said 1 and 3, but I wrote the answer. See how I play tricks on myself? As I was writing down the 3, I was already thinking ahead to adding it to 1 and making a total of 4. Instead, I accidentally wrote down a 4. Okay, so it's X to the 4th. That's the correct answer. Kids, don't be like me. Don't let your brain race ahead and try to give you answers that aren't right. Okay, now what we're going to do is we're still going to be using the product rule, but we're going to complicate things just a little bit. It's not too bad. 21.5. Let me just check and see how many more problems we have. I think it's important to know psychologically. 1, 2, 3 more, and then we're done. All right, so now we're taking the product rule and making it a wee bit complicated. The hardest part is writing it all down. I'm going to start on the next page. Guess I have to turn the page. Hey, this isn't for chimps, you know. Not everybody can figure this out. You have to teach and turn pages. I'm telling you. Don't think it's easy. Okay, ready? Now I'm going to write this down exactly the way John does. But like I said, if I was a student doing my homework, I'd put a 1 by that one right away. And I'm having to squish a little bit because this is such a long string of numbers. All right, I'll double check while you finish writing it. Okay, now notice these plus signs and minus signs in here. They're telling us to add and subtract, okay? It's not just like multiply by a negative number. It's saying subtract, add, and subtract. So what these signs are doing is creating different terms, right? We have 4 terms in total. All right, before everything was just being multiplied in one big chunk. Now we've got it broken into chunks. We can apply the product rule to each term or chunk, but we can't go all the way down the row. These plus and minus signs break up the action, and we're only allowed to use the product rule within each individual term. So that is what we'll do, and we will be careful. And again, if I were a student, I would fix this before I wrote it down. We're going to make sure every base has a number, and if that means we have to add a 1, we're going to do it. And we're going to put them all in alphabetical order because we want to see if we have like terms here. And it's much easier to compare if the terms are in alphabetical order. That's why I do this, you guys. It's not just because I'm OCD, because I'm really not. It's just to make it a lot easier to do our work. All right, sometimes students scratch their heads and wonder if I'm just making this unnecessarily complicated, or if I just like drama, or if I'm just trying to be fussy about this. I will tell you this, you guys, I've been teaching algebra for 20 plus years, and what I have learned is what you're going to need to know further down the line. So I don't like to waste energy on anything that isn't important, but I also know what's coming, and you don't have that advantage. So I ask you to trust me, and if I tell you to write things down a certain way, trust me that that's going to be easier either now or in the future. That may be, you may just be like, oh my God, mind blown, that helps me so much. Right now you don't know that, you just have to trust me. So trust me, okay? All right, I'm putting the first term in alphabetical order. P to the 5th, x squared, y to the 1. Plus, now the numbers always come first. P to the 5th, x to the 1st, y squared. Those are not exactly the same, are they? By writing them in alphabetical order, it helps me see, oh, it's close, but not exactly the same. Y squared, x squared, y to the 1, y to the 1, x squared. It's ever so subtly different. So we want to keep track of that. Plus 3, okay, this one looks good. P to the 5th, x squared, y. We see, this is like this one. Minus 7, p to the 5th, x to the 1st, y squared. So what we see is that 2 follow this pattern and 2 follow that pattern. Notice that I'm just putting squiggles and double lines. There's no rhyme or reason to which one I choose, right? There's no reason I put the squiggles on these two and the underline, double underline on that. I just make them look different, and I do whatever I feel like doing. Heck yes, I'm a rebel. I do whatever I feel like doing. You guys, seriously, I am kind of a rebel, which is good for you because it says I'm not going to make you write it out some long fancy way just because that's what math teachers like. I'm very practical, and I don't waste your time. I don't want to waste your time. All right, now we're ready to combine these. I notice this one doesn't have a number in front of it. Just like we can add a 1 as an exponent, we also can add an angel 1 right there if it's going to help us out, right? We can always add a coefficient of 1. All right, so these two go together. It's 1 plus 3. That gives me 4 p to the 5th x squared y. And then I combine these two. Plus 2 and minus 7 is minus 5 p to the 5th x y squared. Notice I decided to drop my 1s off of these, the y here and the x here. I don't need them. There's no sense in writing them. That's the right answer. Do you feel smart? Look at how complicated that problem looks. But you're like, it's fine. I mean, it's not necessarily easy, but I can figure that out. It's because you're smart. Okay, here comes another one. It's long, you guys. I have to work really hard to squish it into the space. Ready? I'm going to go over to the edge. Here's the first term. There's the second term. And here comes a fourth term. Yikes. Okay, hopefully your paper's not as crowded as mine. Again, I've done what I don't want you to do. I've copied it down exactly as is. If I were a student, I would fix these as I copied them out of the book. So let's do that now. We'll go alphabetical, n cubed, and we'll make sure everybody's got an exponent. Okay, I stop and think, okay, those two match exactly, don't they? Right? M to the 3rd, I just compare them as I look. And that's why I think about it as I do it. M to the 3rd, P to the 1, X to the 1, Y to the 2. Let's see what happens with this one. minus 10, that stays the same. M to the third, P to the 1, X to the 1, Y squared. Oh, those three all match, don't they? And now let's get this last one in order. And I'll give it a 1, just so it's got 1. M to the third, P to the first. Uh-oh, look what John did. X squared, and then Y to the 1. This last one, he flipped the exponents around, right? All of these were X to the 1, Y to the 2. X to the 1, Y to the 2, X to the 1, Y to the 2. And here he flipped it on us. X to the 2, Y to the 1. Once there's a difference in the term, we can't combine them. We can only combine like terms, and that applies to exponents as well as the letters themselves, right? Obviously, the numbers can be different and the signs can be different, but the letters have to match exactly, and that applies to the exponents as well as the letters themselves, the bases and the exponents. So that means this one, and this one we can combine, but this is the offbeat child that cannot be combined. So now that we've determined these all match, we can ignore them and we can just focus on the signs and the numeric coefficients. 2 plus 3 is 5, minus 10 gives us minus 5 of this big long thing, m to the third, and I'm going to drop the p's now, we don't need them. And then this last term stays exactly the same, it doesn't change, and I can see I don't need the 1, so I'll drop that out too. M to the third, P, X squared, Y. Close is good enough in horseshoes and hand grenades, but not combining like terms. They have to match exactly. And these guys messed up. I'll tell you one thing though, when I'm doing something like this and I can see I'm really, really close, but maybe it's not matching exactly, I double check back in the book to make sure I copied the problem right. And I might just check through my process to make sure I didn't make any little mistakes, because sometimes we can introduce that little hiccup, right? But no, in this case, that's the right answer. Yay. 21.7. Almost done. Yeah, this is the last one. And it's another long one. Okay, that's the way it's written out in the book. I'm going to write it again, and again I'll say this. You're probably wondering why I keep repeating myself. I'll tell you. But this is the way it is in the book. What I would do if I was a student is I would copy it with all of these terms in the alphabetical order with ones wherever we need them. So 2x squared y to the 1 plus 3x squared y to the 1. Okay, so we can see those two match. Plus x squared y squared, those don't. Minus x squared y minus 4x squared y squared. Okay, so this one matches with these guys, right? We have 3 of those fellows. And then this term and this term match to each other, but not to the others. All right, I'm going to slip a 1 here and a 1 here. Put those angel coefficients in to make it a little easier to see what I'm doing. And now I'm ready to start. I'll combine the first ones, and I just go in order, by the way. In something like this, I just take, this is the first one, so let's find all of his friends. 2 plus 3 is 5, minus 1 is 4. X squared y. I didn't need those ones, so I just dropped that off. And now this one, plus 1 and minus 4, that's minus 3. I'm climbing on that ladder in the meadow, did you notice? And that is x squared y squared. That's our final answer. We cannot combine those two because they are not like terms. And I'm going to write this down for you so that I'm communicating it as forcefully as possible. like terms means that all the letters and their exponents, this is the new part, match exactly. Before, we didn't really throw exponents on top of our letters, so we just were worrying about making the letters match. Now it's letters and their exponents. Here's an interesting thing that brain scientists have determined. It takes us, and this is all of us, this isn't just like teenagers or math students or something patronizing like that. It takes all human beings, we have to hear something 7 times before it really settles into even our short-term memory. 7 times, you guys. That's why I repeat myself. I know you heard me say it, and I can feel you rolling your eyes sometimes when I'm really leaning in, but I'm trying to make sure you get all 7 times so that you'll remember what I'm telling you when you actually go to do your homework. Notice that that is only to get it into your short-term memory. To go from short-term to long-term, it takes about 10 years. What the actual heck? I know. That's why it takes so long to learn your dang times tables, and why I don't get upset when students who are, say, 15 years old don't know their times tables hard. I understand that because you didn't start learning your times tables when you were 5, right? If you were 5, then it's been 10 years and you probably know. That's why I trust that you know, like, your ABCs, right? You've been learning those for at least 10 years. But most, even the basic math, it requires me reminding you to freshen up your short-term memory, and eventually it will move. But that's why I repeat myself over and over. Okay, guess what? I'm going to repeat myself now. We're done with this lesson. Yay, thank you, goodbye.